Hello, everyone. How are you doing, guys? We here and another day the campus jobs on. Sorry, and SouJava on campus, and I will show it this event to you now. We have a lot of places here, a lot of stages. And to back to me, we have it Arena's Hoop Zone, where they have a lot of talks in the SouJava. We have a coffee. We have a lot of communities here. Um, and then here we have the principal stage. We have another persons in the events. Today it's very cool because here in São Paulo it's very hot, and I had a little açaí because this is possible today. And Oliver, how are you, my friend?
Hey man, how are you? I am very happy to be with you. I am from Guatemala, so I am very happy to be in this event.
The weather in Guatemala is very hot today, or it's okay. In São Paulo,
N-
Brazil, it's very hot.
No, right now it's kind of cold. I don't know
Oh,
what is my temperature, but it's kind of cold right now. Yeah, because I am from Quetzaltenango. It's near from Mexico, so
yeah.
my country is like 2,300 meters from the sea.
Oh,
So
say
so it's kind of cold. Hey Maximilian, nice to see you.
Maxon send a message. Hey guys, and Maxon say it's live in Brazil. And guys, right here in the chat, where you're live, this is very important to us. Okay, and Oliver, this place is to you. Thank you more one time to accept the invite given talk to in SouJava on campus. And this place is totally to you. And if you have a questions, you can screen Gabriel and I return here. Okay, I will go to backstage now.
Okay, thank you very
Okay.
much. Nice to see you, Maximilian. Okay, awesome. Okay, hi everyone. For me, it's a great pleasure to be here, and I hope this talk will be interesting to you. I think that when I proposed the talk, I think this name for the talk, but when I was creating the slides and I was talking with my brother yesterday, we realized that the name is kind of different at the end. But I hope you enjoy that. And the name of the talk is how to use of the domain diagram can help you to not to worry about inventing the variable names when you are developing. And this is a there are a lot of memes about the naming variables. That's the reason why I think in this talk in this way. Okay, my name is Oliver Ernesto Sierra Pac. As I said, I am from Guatemala, Quetzaltenango in specific. I am near from Mexico, and I am very happy to be here, and I am very happy to see a lot of friends that are in Brazil. So if you want to follow me, I am in most of my social networks as a Moroccan. Okay, so thank you very much, and we are going to start. I want to start talking about when you are working on a project. Usually, you're not the only developer in the project. You need to communicate with a lot of people, and when you are communicating with a lot of people, it increases like the importance of a good communication, because when you are communicating, if you use the words or the terms of the words in a bad way, the communication will fail, and this decrease the productivity, and maybe could make like a hard work to follow all the projects and continue with the work. That's the reason why it's important to communicate in a good way. And beyond of that, it's important to all the team members understand what we are saying when we say something. And this is where domain driven design can help us to communicate in a better way. And After all, when we are coding, because I think that that's a part of an important thing in the project, we are coding with the exact words and the words that mean everything we need. And we can have our code as a documentation, so we can create a better communication between each other. In that way, the agenda of this talk, I'm going to talk about the basics first, because it's important, first of all, to review the computational thinking that I think that we can solve the problems with computational thinking even if we don't see that we are using computational thinking. So we're gonna to a quick refresh about computational thinking. Then we are going to talk about UML, Unified Modeling Language, because as I said before, we need to communicate each other in a good way. So we have to, or we need to have a standard to communicate. In this way, we are going to use UML in order to communicate with our team. So after we see the basics or review the basics, we are going to understand a little bit more about domain-driven design. And I think that the problem or the business domain is the most important part of this, because we are going to focus on how the problem works and how we can communicate the problem. In order to that, the computational solution that we can make, uh, the problem is a important part of this. Then we have like the domain diagram that can help us to represent in a good way the whole problem. And to create our class diagram, we are going to use the domain diagram of the problem. Okay, but another part important, since the name of this talk is the vocabulary, because when we use the same vocabulary that it came from the domain diagram that we we done before, we can communicate each other in a good way because we are using the same vocabulary and we are using the exact words to communicate what are we doing and what are we solving. Okay, so first of all, we have like the analysis and design part here. Then to software develop, we have like a lot of goals, like cohesive, coupling, and other things. But in this talk, we are gonna focus as the communication that can or enable to be a good communication based on we are basing everything from the problem and creating a vocabulary. So the goals are code as a documentation, because it's important that our code express in a good way what are we doing and have a cohesive code and the communication itself, because if we talk and we solve problems with our teammates and we speak in a good way, we can communicate good. And last thing that we are going to discuss is the variables name based on the vocabulary. Okay, so go ahead. The computational thinking first of all. When we are solving problems, we see that the problem is like big or it's very complex, and that creates a few problems because sometimes we want to start to writing a code and solving the problem, but sometimes it helps us to like take a breath and then analyze the problem. And to analyze the problem, it helps us the computational thinking. The first of all, there is like 5 principles for the computational thinking. The first of all is abstraction, and abstraction means that we are going to focus on what need to focus, but the focus depends on the context of the problem that we are solving. So if we are managing data for from persons, the data that we need to manage will differ if we are doing software for an hospital or from an education, I don't know, university or something. So the information that we need to handle is different. So it's important to notice the context of the problem. It's important to achieve or to focus on what really matters. So that is abstraction. Then when we realize what data we need to handle, we can take the problem and the composition of the problem. And it refers that we have like a big problem, and we are going to create or separate in tiny problems. In each tiny problem, maybe we can create another tiny problem, and so on. And the composition allows like a human to have the whole visualization, and we can solve tiny problems in an efficient way, in a better way. And when we take together all these tiny problems, it's very easy to solve like biggest problem. So that is the composition. Then when we have like the puzzles of the problem, the each piece of the problem, we can or easily recognize patterns. And why we need to recognize patterns is because it's easier, or we don't need to write the code or solve many times the same problem. So in many problems, in many projects, we are going to solve the same thing many times. So it's important to solve it one, and we can use it everywhere. Okay, and this is pattern recognition. Then we have algorithms, because this is the easiest part, because we have like the whole problem, and the whole problem right now it's in the little pieces. So solve each piece of each tiny piece. It's very simple, because the algorithm will be simple. And when we mix everything together, every algorithm will be simple. But there is the last thing that is very important, and we need to do in, I think, in everything, is testing. So everything we do, like seeing the context, creating the parts, the tiniest parts, pattern recognition, algorithms, we need to test. We need to test that we are focusing on solving the real problem, or the problem that we really need. So that is the important elements in the computational thinking. So when we have the problem and we can split it, we can see that each part has like their own goal, their own purpose in the problem, and we can solve in a good way. So it will be easier for us to solve like more complex problems. Okay, then we already do this like mental exercise, that the computational thinking, but we usually need to communicate with your teammates. And when you are communicating with your teammates, we need to first of all use a common language and a standardized language to communicate each other, in order to we can understand, and we can say the words, and the other person understand, because the meaning is the same. So it's important to that, to have like a unified language, right? So using the computational thinking, we can pass to create things in UML. And first of all, we are going to discuss the domain model. So it's important to understand that when we are creating a domain model, we are not creating classes or objects, but we are like discussing, and we are modeling concepts, and we are taking the problem and splitting the problem and defining the problem in some terms. So in this next slides, I'm going to talk about the problem. And the problem that we are going to face in this time is the tic tac toe. I think that every one of you knows the tic tac toe, and you already play with the tic tac toe. So before that, the relationships, or the most important relationships that we are going to discuss, is aggregation, composition, inheritance, association, and dependency. Okay, tic tac toe is this game that we can play like in a very easy way. So we have like square and a matrix here from squares, and a, someone creates a mark to an X and a mark on an O, and wins the person who can accomplish one line of their marks. That's the goal of the game. So creating that, and we are going to start to creating our domain model based on this game. So I think that every one of you have played this game. So I'm not gonna start uh, like take more time talking about the game. So first of all, I'm gonna talk about the board. Okay, the board is a concept that a place where we can make all our or put all our marks in the to win the game. Okay, so board it's a concept. Like a concept, it has like many things that conform the concept itself. To that, I'm gonna start talking about the composition. I can say that the board is composed by a square, by a square, because uh, we have a many squares here, and we can say that board is composed by a 3 by 3 matrix of square. So we are defining the concept of the board right now. Okay, so the composition usually refers that something that makes or is part of another concept, and if you don't have the square, the life cycle of the board will end also. Okay, it's a strong relationship. It's a very strong relationship. So the board is composed by square, a matrix of square, but we have like more concepts, and here we have marks. If you can see, each square can have a different marks. At the beginning, this square was empty, then it has an O, and this square was empty, and then we have an X. So I'm gonna say that these squares aggregate a mark because it's a part of the square, but it changes in the life cycle of this game. So I'm gonna use the aggregation symbol here. So I understand that the square aggregates some marks, but we understand that this mark can change in the life cycle. Okay, then we understand that this mark can have like different values. It could be empty, it could be X, it could be O. So this mark itself, we can say that it is X, O, and empty is a specification of a mark. Or the mark is a generalization like that. And we can see it as inheritance because a mark in X inherit a mark, but it's an specialization of a mark because right now here we are showing or defining our board, and our board can have a or can model each one of these boards that we have here. So we are working in a good way. And referring to a domain model, it's important to notice that we are defining concepts. I am not thinking right now in classes or how I'm going to implement this. It will be an enumeration or not. I'm referring to a concept and how the concept can work each other. After that, we are going to talk about classes. Okay, but we also have a player. The player aggregates a mark because each player will have an X or O mark. Okay, but this player will help me to create a new relationship, the association. The association refers that the player associates with the board, but the board isn't a part of a player. Me, like a player, use the board in order to put a mark in some place or play with another people, but isn't a part of a player. Uh, Conceptually, isn't a part of the concept of a player. That's the reason why I used here the association here. Okay, but the players also have many goals. They have some goals. One of the goals of the player is win, and the player can win making a row, a column, a diagonal, or an inverted diagonal. But another goal of the player is put. I'm gonna say that these many different categories of how the player can win will be a specification of the goal. But we're gonna say that the goal itself uses this action that is put to in order to put a new mark on the board. And I am saying that the goal is to put a new mark in new coordinate, and the target will be the square, the matrix itself. So I am using a dependency relationship here because, and it's a dependency because whenever we put the mark, we are not gonna use the recording of this event like that. So we don't need it like that, and it helps me to represent all this transition that is important, but it's not a part of the player like putting the mark, but it's an action that the player needs to do. And so summarizing all that I try to say, we can say that the composition is a lifetime of the object. Lifetime of the object is identical to the other. Okay, when you use composition, if we destroy one of the objects, all the other objects will be destroyed. An aggregation usually means that owns another object or it's part of me, but it can change. Inheritance, it's inherited the properties and or the behavior, and we can create a new specific ones or add something else. Dependency usually used to point that we are gonna use some object, but it's like an temporary use. We are not gonna track or this use like the whole time. And association, it means that we are gonna store some object to use the object. It's kind of or many very similar to dependence, but we are gonna store the other object because we need it in a longer time. So this is like a summarize of the what we discussed right now, and we are going to uh, talk about the domain model. We are we starting creating the domain model of the tic tac toe here, but the domain model we can say like that. We can say that tic tac toe is composed by players, and it's composed by rounds, and it's composed by a board. And a round has two players or use two players, and a player has an specification. We can have like a human and intelligent artificial intelligence or whatever, and a player also aggregates a mark because the player need to have to know what marks it's assigned to them, and the player has so many goals. Between the goals, we said that he wants to win, and there is the different kinds that a player can win, and the goals is that also put a mark on the square on their board. Okay, so these relationships describe like the whole problem or the whole the whole problem that we are solving right now. So we have our domain model from here, or taking this like an important concept, we are going to build our software, and that is the importance of the domain model, because if we are going to talk about rounds, we understand that round refers at each turn of the players, because in this domain model we define so like a round. That's the importance of use the correct words or the correct terms to name every action, every part of the problem here, because we expect that everyone that works in this project understand that O means a mark, X means a mark, empty means a mark, and each concept has the meaning of that. And this diagram allows to communicate with our team, and allows to our code be more expressive, and think our code as a documentation itself. We don't need create like a lot of documentation, but we can use our code as a documentation. If someone else came in this project and understand this diagram, maybe it will be easier for them to understand the rest of the code. That's the importance of that. So taking this domain diagram, we can start to creating our classes. So right now here we are starting to talk about classes, because we already define all the problem, and we focus on the problem and the relationships between each part of the problem. And when we have that, we can create in an easier way or class diagram, and we can name every every variable in our code in a good way. We don't need to use our imagination to name variables, to name methods, because the domain diagram done that. But I think that the important part, or the most important part here, is to create when we create our domain diagram and use the right words and the adequate terms for each part, each action, each attribute, and everything. So this is the important thing, that we have like our domain model, and here we have a or class diagram. I think that I have like a few mistakes here, because I made this after that, and I don't have time to correct this, but it should be, or it should use the same terms here and in this diagram. And that's the reason why, if you use the main diagram, we don't need to improve or create or imagine the variable's name, the object's name, and we have like a good uh, class diagram to start developing. How can we develop here? I think that top down it helps a lot, because you understand almost the whole project, and you can start working on the tic-tac-toe, then go uh, up to down using the hierarchy that we can create here in our class diagram. And in conclusion, I think that I can say the conclusions are that the importance of the main business problem is that sometimes we focus on writing code or trying to solve the problem before understands the problem. So I think that the importance here is to use the problem, or use the business domain to define the concept, the main terms that we need to use, it will be like or create that our team could be or have a better performance. Then the other thing is standardizing the communication, improve the performance on our team. And we can create like a clean code, a better code, a more cohesive code. And we can see in a good way if our code is like so coupling or the coupling is okay. And I think that it helps us to create and have a better communication each other in our team, and the documentation also it's very easy to do. And that's my talk. I don't know if I speak so fast, Christian. I don't know if you're there, or I don't know.
You need help? It's okay.
Hey,
Every- It, all things okay?
yeah, I finished my talk because I don't know if it was for half an hour or it was for an hour.
Sorry, I understand you.
I finished my presentation right now.
Oh, all right.
I don't know if I speak so fast.
I think you speak a little fast, but no worries. You have a time if you want to introduce another thing. And this moment in the chat, you know that they have questions in January.
Yeah, I don't know if someone want to tell
Yeah, I
her
send
their
questions
opinion.
questions here. It's very important. Max, you walked into his talk. Yeah, I don't. I think don't have questions, Oliver.
Okay, no worries. I'm sorry to speak so fast. Yeah, I don't know.
No worries. It's normally have moments I speak very fast. Like I give you my example. I in the Saturday I was given talk in the stage jobs here, and I speak so fast, and I have I think 15 minutes, and I finish my talk. And oh my gosh! And now
Yeah, yeah, yeah. That's a big trouble, but I don't know. What do you want to do?
no, your talk is it's amazing. It is very very cool. Oh, it's very hot here in the
Because
little muskets.
no
Go
worries.
ahead.
Because if you want, we can create like at least the first classes to see how to use like top down programming to solve this problem. I don't think that we have the time to program the whole tic tac toe, but we can
Yeah.
start creating something.
Oh, okay. Oh, and I think having a person is giving hello, Bruno. Bruno. And I am here with you, Oliver. I am here with you, Oliver. Yes.
Hey Bruno,
Hey
how are
Oliver, how
you?
you doing, man? Doing great, man.
I'm doing great, thank you. And you, how are you
Okay,
doing?
awesome. I'm doing great too. A little tired of the event here, but it's all good, all great, man.
I can hear your voice because it sounds tired.
Yes, exactly. So who's the little dog there?
It's Tux. It's my dog.
Tooks.
Yeah,
Ah, okay, nice. All right,
yeah. He usually be with me. Right now is isn't here, but usually
cool,
it's my
nice.
company.
So thanks, man. Thanks for being here with us. Thanks for making this event greater. Thanks a
No,
lot,
thank
man.
you. Thank you for inviting me. It's a pleasure to be here. I hope the next year I can be in person in Brazil.
That'll be awesome. That'll be great, man.
Yeah, of
Cool.
course.
So are you answering questions now, or are you just starting your talk? I don't know.
No, I finished my talk because I think that I speak a little fast, and I
Right.
think
Okay. So yeah. So Max saying it's interesting to learn how to name our variables. Thanks, Max. Awesome, man.
yeah. Thank you very much. Thank you very much. I don't know. I don't know what do you want to do because I don't know how many time I have.
So are you finishing now, or? Okay. So yeah, we're finishing now, man.
Okay,
All right.
awesome.
So yeah, I'll pass back here to Gabriel because he knows what he's doing. I was just passing
Yeah,
by and he brought me here, so I have no idea what's going on.
yeah. Okay, nice to see you, Bruno.
Thanks, Oliver. It's good to see you here, man. Thanks a lot for being here with us, man.
Okay, thank you very much.
Awesome. See ya.
See you.
Hi, Oliver. Hi, back. And, thanks to join with you with the, we and give it to Stalk and in the SouJava on campus. And I hope we see you in next year here to this amazing event. Next year have another edition of the SouJava campus. And you is a great person, a great speaker. And I wait to see you in the next year.
No, thank you
Thank
very
you, Oliver.
much. I hope I can be in Brazil. I was like in August. I think that I came
If you
to Brazil.
if you visit Brazil, send a message to
Yeah,
to schedule a barbecue.
yeah. Of course, I love the barbecues of Brazil. Are amazing, man. Yeah, the
Okay,
steaks are amazing. They're
and
delicious.
the
Well,
Brazilian barbecue is amazing. It is true.
yeah. Thank you very much. Thank you very much for the
Thank you very
opportunity,
much.
and it is an amazing event. So congratulations to you, to you. So thank you very much.
Thanks. And guys, if you have questions about how declare its variables, you can send message to Oliver, and you can find Oliver in my social medias because I share you talking in all social media, my all social medias.
Okay. Thank you very much. Thank you very much, man. Awesome.